In case you didn't know, the sun is bigger than the Earth. Yes, from here the sun looks like it's no bigger than the moon, but that's because of how far away it is from the Earth. 150 million kilometers to be exact. So how big is the sun? The sun's radius is 695,700 kilometers. The Earth's radius is 6,371 kilometers. That is a huge size difference. The sun is so big that 1.3 million Earths could fit inside it, and the sun makes up 99.86% of the total mass of our solar system. So in short, the sun is really big. But let's imagine for a second, what would our solar system be like if the Earth were bigger than the sun? Hello and welcome back to Life's Biggest Questions. I'm Charlotte Dobre. Don't forget to like and subscribe and let us know in the comments below what topics you would like to see next. Firstly, if the Earth were bigger than the sun, everything about our solar system would change. Currently, the Earth's conditions are ideal for supporting life. The conditions are supported by an equation where the size of the Earth, the distance between the Earth and the sun, as well as the size of our moon all add up to equal life. Change something in that equation, especially something having to do with the sun, and it's likely that life on this planet would no longer be possible. Primarily because, well, the Earth would be so big, the gravity would be so great that your bones would instantly break. That being said, if the Earth were bigger than the sun, depending on its density, it would start fusion in its core and would become a star itself. Any planet more than 13 times the mass of Jupiter, which is roughly 4,000 Earth masses, generates enough heat and pressure in its core to create fusion reactions. The Earth would therefore be classified as a star, not as a planet. Then our solar system would be a binary star system. Binary systems are star systems that consist of two stars orbiting around their common barycenter. Binary star systems are not uncommon. In fact, statistics show that around 80% of the stars in our galaxy are binary stars. At the same time, if the Earth was larger than the sun and also had more mass, the sun would revolve around the Earth. That's how gravity works. The object with the most mass is the object with the greatest gravitational pull. Another thing that would happen is the entire shape of our solar system would change. It's likely that many of the other planets wouldn't exist because either the sun or the Earth would engulf them. The outermost planets like Neptune could likely still exist because they're far enough away. So we know that it would be impossible for life to exist on Earth if it were bigger than the sun. But does that mean that life would cease to exist in our solar system entirely? In binary systems, one or more stars is constantly moving farther and closer from its planets. This changes the amount of light, heat, and radiation those planets receive, which ultimately would affect the possibility that life could evolve there. Planets can exist in multiple star systems. In fact, a frozen rocky planet was recently discovered that was orbiting its two parent binary stars in a stable Earth-like orbit. That being said, the gravitational pull from more than one star can interfere with the stability of a planet. Not only that, but having two suns raises the chance of a moon being able to support life. In fact, moons have a better chance of being able to support life in a binary star system than a single star system. According to the American Astronomical Society, binary stars dampen each other's solar radiation and stellar winds, which means they create a more hospitable environment for life, as well as increases the habitable zone. When you got a really active bright young star, that bright young star spins really fast, making them quite violent. Lots of stellar winds and radiation would make it difficult for life to form near it. But add another star and create a binary system, and the other star actually dampens the effects. Two stars in the same system would actually synchronize their spins. How cool would it be to live on a moon with a planet and two stars in the sky? What a view that would be.
The moon, our cheeky little orbital. The moon is less than a third of the size of the Earth in diameter. According to our mates NASA, if the Earth were the size of a nickel, the moon would be a coffee bean. But what if Earth was bean-sized? Hello and welcome back to Life's Biggest Questions, the channel that loves to answer all manner of things, big and small, because we believe that every question deserves an answer. I'm your host Rebecca Felgate, and today I'm asking, what if Earth was the size of the moon? Before we delve deep into this video, I want to ask you guys if you think humans will ever commercially go to the moon. Like, will we vacation there? Will we get little hats that say moon on? I love the moon. Moon! Let me know your thoughts in the comments section down below. Also, while you're down there, why don't you hit that thumbs up button and share this video with a friend that you think will find this interesting. So, Earth the size of the moon. What would that be like? Right now the Earth has a diameter of 12,742 kilometers and the moon just 3,474 kilometers. That is, if my sometimes dodgy math were correct, 27% the size of the Earth, so between a quarter and a third of the size. Assuming the makeup of the Earth was much the same but we just shrunk, well, things would be very different, obviously. The Earth would have less mass, which means that it would rotate faster than it does right now. Currently, the Earth rotates on its axis every 24 hours. This is an Earth day. If the Earth were just 27% of its current size, then days and nights would be much quicker. The least of our issues would be sleep patterns, although yes, this would be strange to us indeed. And if Earth had always been teeny and fast, well, maybe we would have evolved differently, as our brains would work differently with a different measure of sleep. While the length of the day would be shorter, the length of a year would change too, and perhaps the gravity of the sun would have a greater effect on us, drawing us closer, which would mean fiery hot death. Although, let's just assume we stay put for the sake of this video for now. So on the topic of gravity, if the Earth were moon-sized, even with our same structure, our same core, the mass of the Earth of course would alter, which means our gravity would change too. With less gravity and a faster spin, we could be in danger of losing our breathable atmosphere, which could mean being exposed to harmful radiation, and worryingly, losing some of our oxygen. This would have a profound effect on plant life. The smaller the planet, the faster it cools, which means less geothermal energy. If our core cools, we will use the Coriolis effect, which has happened to our neighbor mate Mars. This means we would be at even greater risk of losing our atmosphere. Okay, so a smaller Earth on a physics level isn't looking great, but what about on an anthropological level? How would we humans handle having less space but the same population? There are 7.5 billion people on Earth. In the year 1900, there were just 1.6 billion. In 120 years, we've gained 6 billion people, and that is actually mental. So where would we fit everyone? Funnily enough, we'd fit alright. If everyone on Earth stood shoulder to shoulder, we would all fit in the space of roughly 500 square miles, so a city roughly the size of Phoenix, Arizona. Right now, there is 57,308,738 square miles of land on Earth, although about 33% is desert and 24% is mountainous regions. Subtracting this uninhabitable 57% still leaves 24,642,757 square miles of habitable land. If Earth were moon-sized, we would have 6,653,544 miles of habitable Earth to play with, which really is enough to physically fit all of us comfortably. The issue, however, comes from having enough land to farm with enough fresh water to drink. With the Earth the size it is right now, we're already struggling. There simply wouldn't be enough resources. A smaller Earth just couldn't sustain the current population. Maybe we could pull a Xenu and round people up, pop them in a volcano and nuke them. Niche Scientology references, anyone? Good. Great. If Earth is moon-sized, what about the actual moon? Would that be Earth-size? If so, it would be a tidal wave nightmare and we would start orbiting it. If it stayed moon-sized, however, perhaps we would be two wee cosmic sisters. Perhaps our gravities would influence one another and we would create a gravitational vortex between us. Ultimately though, questions like this are very hard to answer on a deep and intricate level because everything on Earth is the way it is because the Earth is the way it is. We've evolved to our Earth, we are the way we are, and life is the way life is because of the conditions Earth has given us. Maybe if Earth were moon-sized, we will have evolved to be miniature versions of ourselves, but then again, maybe not. The likelihood is there wouldn't be life at all, or as we know it anyway. Sorry, tiny Earth, you just aren't the one.
Jupiter, the fifth planet from the Sun, is the biggest planet in our solar system. A gas giant 11 times the size of Earth and 318 times as massive. In comparison, our Earth is tiny. The Earth is around 7,900 miles across. Jupiter's diameter is 87,000 miles. But what if Earth were as big as Jupiter? How would that affect the life forms and planet itself? That's the question we are asking today on Life's Biggest Questions. Hello and welcome back to Life's Biggest Questions, the channel that asks the fundamental questions of life and occasionally answers them too. I'm Charlotte Dobre. Why don't you hit that subscribe for more daily questions that will have you asking more questions. Jupiter has been known to astronomers for thousands of years, but it was first observed closely by Galileo using a telescope of his own design. It's a huge planet, far bigger than than our own. Of course, life forms do not exist on Jupiter because it's a gas giant, but life forms do exist on Earth. What would happen if the Earth were the same size as Jupiter? Firstly, there would be a lot more land and therefore a lot more space for people and wildlife. Imagine a North America that's 11 times the size it currently is. It can be assumed that much of this massive planet would remain uninhabited, and it would have taken a lot longer for it to become populated. There would also be far more water and other resources on this planet. But whether or not life forms would still exist is another story. If they did, they would likely look a lot different than the life forms that currently exist on Earth. If Earth were the size of Jupiter, it would exert a far greater gravitational force. Jupiter is a gas giant, but the Earth is mostly solid rock. Because of this, the super Earth would exert a gravitational force 100 times greater, which would make it very difficult for life to move around, if there was any life at all. According to Wolfram Alpha, this much gravity would cause either extreme injury or death for humans. I mean, you're multiplying your weight by 11. That's pretty heavy. Essentially, our spines would crush under our own weight. If life forms did exist on this massive planet, they would be very short or small. Ever wonder why astronauts grow taller when they're in space? Lesser gravity allows the fluid between the vertebrae to expand. The opposite would happen with more gravity. The life forms that would exist on this huge planet would also move around very slowly. It would be very hard to jump, climb, or run. Life forms, if they existed, would grow tired very quickly and require a lot of time to rest. On a Jupiter-sized Earth, the life forms would be sturdy, with muscular limbs, kind of like beefed up corgis. I don't know why I thought of that, I just had that image in my head. Plant life would also be much smaller, and would also have to be made up of far stiffer fibers, or be made out of another material altogether. It would be difficult for plant life to grow very tall at all. Right now, there is actually a limit on how tall a tree can grow, and that's because of gravity. A tree keeps growing for as long as the amount of energy it gets from photosynthesis is more than the amount of energy needed to transport water to the top of the tree. More gravity means it would take far more energy for water to move up the trunk, so therefore trees on this planet would be short. Very short. The climate on a Jupiter-sized Earth would also be much different than our own, likely colder and drier. Weather takes a long time to travel. Rain already has a tough time reaching the center of continents on our planet. This super Earth would also take much longer to rotate, so a day would be much longer as well. The slower rotational speed would also have an effect on the seasons. A Jupiter-sized Earth would probably have a very thick atmosphere, since the gravitational force is so great, and of course, the Earth would become very unstable. More mass means more volcanic activity. Current dormant volcanoes would be constantly exploding, spewing lava and dust into the atmosphere. Increased volcanic activity would also have some pretty profound effects on the atmosphere, and forget space travel. It's already extremely difficult and expensive for humans to leave the Earth. It would be far more difficult if the Earth were the size of Jupiter. Bodies of water would be 10 times the size, 10 times wider, and 10 times deeper. It would be incredibly difficult for life forms to cross huge rivers like this. Because the Earth would be so much larger, it would also attract far more objects into its orbit. In short, the Earth would have far more natural satellites than just our one moon. The gravitational pull would also pull far more space objects toward us. Asteroids and comets would wall up the planet. It's difficult to imagine what would happen to life forms and our planet itself if it were the size of Jupiter. Right now, we haven't discovered any other planets in the universe that support life, so it is difficult to predict. But we hope this video has given you some insight and maybe inspired you to look into the question further on your own.
The sky is a beautiful vista, often full of majesty in the bright tapestry of the glory of our universe. We look up and the constant constellations remind us of our place not only in our solar system, but also as a reminder of just how damn lucky we are that planet Earth hit the sweet spot when the infinite will of the cosmos decided on where to park us. We find comfort in its cosmic consistency, the sun, the stars, and our moon. But what if one day you looked up and instead of just one moon, there were 79? And counting, and all of them are uniquely hostile in their own perfect little way, and that means only one thing. Yeah, let me explain. Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice, Jack Finch, as today we curiously ask the question, what if Earth was a moon of Jupiter?
Damn. That is a sight to behold.
For the curious amongst you, that clip was from sci-fi's incredible science fiction epic, The Expanse, based upon the equally awesome series of novels by Daniel Abraham and Ty Frank, which is possibly one of the best space-themed television shows to grace our screens in the past few decades. It segues us to an important opening point as well, because if Earth was a moon of Jupiter, we better well hope that we've already discovered something similar to the Epstein drive, the spaceship propulsion system featured in The Expanse that lets humanity travel freely across the solar system in efficiently propelled spaceships, because without it, we're pretty much sitting ducks when it comes to the terrifying intricacies of our new Jupiter lunar neighbours. Before we approach this question though, it's probably best that we lay out some of the frightening cosmic fancies of that strange giant planet known only as Jupiter. If you haven't yet seen our video detailing exactly what would happen if you plummeted through the gaseous landscape of Jupiter, then now would probably be high time to check it out. If for no other reason than Jupiter is interesting as hell, and it's a pretty fun concept to imagine hurtling through its many deadly atmospheres in a spacesuit, right? Yeah, I'm glad we're on the same page. Jupiter is absolutely massive. It's the largest planet in our solar system and has a mass that is 2.5 times greater than all of the other neighbouring planets combined, excluding the Sun, of course, because that would just be ridiculous. In fact, Jupiter is so big that it could contain over 1,300 Earths within its mass. Just let that sink in. It's also a gas giant, meaning that many of its planetary properties are colossally different than that of Earth's, warranting to the fact that because of its absolutely massive size, Jupiter's got a lot of love and a whole lot of gravity to affect the solar system with. Enter the 79 and counting moons of the Jovian system, all of them seeking shelter in Jupiter's all-consuming gravity, finding their home in the many layers of the rings of Jupiter. This is where things get interesting, and this is also where Earth would find its home in this particular hypothetical situation. The inner moons of Jupiter are tiny things, less than 200 kilometers in diameter, and are thought to have formed alongside Jupiter way back when in the cosmic soup. These are Metis, Adrastea, Amalthea, and Thebe. Say hello because they're our new neighbours. Alongside these are what is known as the Galilean moons that comprise some of the largest moons in the solar system, some of which are larger than several planetary bodies. These are Io, Europa, Ganymede, and Callisto, first discovered by Galileo Galilei sometime in 1610. Familiarise yourself with these guys, because if Earth was a moon of Jupiter and ended up anywhere other than a similar orbit to these lunar entities, as in Jupiter's outer dust rings, then our planet would be torn apart by cataclysmic tidal forces and scattered to the cosmic winds. And of course, we don't want that. So let's say that our Earth finds itself in the same orbit as Europa, a small moon made up of silicate rock with some incredibly interesting mechanics. In the same orbital distance, our days would last around 85 hours, with up to 15 of those hours caught in the shadow of Jupiter in a weird kind of day-night-day daily pattern. Also, by that principle alone, Earth just got super cold, and also, in all likelihood, our planet would become tidally locked to Jupiter thanks to its massive gravity, in a way similar to how our moon interacts with our planet. Being tidally locked would result in a very strange scenario, where one half of the planet dries out into an arid desert wasteland, and the other half turns into a frigid frozen ice cap of constant Arctic winds and snow. This isn't too great of a position to be in, but it's not all doom and gloom, because our species could actually survive this, and in areas near the middle of this newly founded geothermal landscape, humanity could find a pretty comfortable home. However, it's not all tippity-top, because Jupiter's a pretty dangerous dude, and this whole time he'd be spewing deadly amounts of radiation in our direction. That's not good. But also, don't worry, because we are in fact the lucky wielders of the shield that guards the realms of mankind, our magnetosphere, and in this hypothetical situation, that same shield that protects us from the sun's radiation would be fit for the task to protect us from Jupiter's as well. Thank you, Earth. We love you. But Jupiter's not done with us just yet, and this particular boss battle just segued into phase 2. Because of its massive gravity, Jupiter has a strange effect on its many moons, and in essence it heats them to a point where its celestial influence almost kneads them like a ball of dough. Because of this strange influence, our Earth would become a hell of a lot more volcanic than it is now, and pretty much every volcano across the planet would be spewing out a constant stream of carbon dioxide into the air. Under any other circumstances, that would be known as a very terrible thing, but given the fact that in this situation our planet is tidally locked to Jupiter and half of it is frozen in darkness and ice, we would actually welcome a bit of global warming. I guess we just have to adapt to all of the clouds of sulfur and torrential downpours of acid rain. hopefully. In actual fact, whilst it's easy to imagine Earth being a moon of Jupiter resulting in the end of our species, we could actually survive the whole ordeal given a bit of grit and determination, albeit with a much smaller population, down to the fact that we've got to deal with a couple dozen environmental disasters throughout the process. And if we did, we've got a whole host of cosmic phenomena to look forward to. The main one being, well, Jupiter in the sky constantly, over 40 times the size of the moon. And we wouldn't just see Jupiter, but all of our other new neighbouring moons, Io, Callisto, Ganymede, as well as all of the many smaller moons, perpetually dancing in the atmosphere alongside a beautiful cascade of lightning and a permanent aurora from the Jovian system. And if we did manage to survive the whole process and then also advance to some type of space flight such as the one that we mentioned earlier, then we've got a whole new backyard ripe for the picking and the harvesting of some insanely rare and valuable metals, ores and chemical compounds. In fact, with our proximity to Jupiter and our new tidally locked relationship, we'd have a fixed point perfect for shuttle launches and general spaceflight, so there'd be even more reason to invest in the exploration of our 79 new moon neighbours, as well as the rest of the solar system. So, how about it then, guys? What do you say? Who's up for moving to Jupiter? Have you ever thought about that old saying, it's a small world after all? Now, whilst being a pretty terrifying and insanity-inducing amusement park ride, as well as also being a nice, heartwarming testimony as to our interconnectedness as a species, it's just plain wrong. Our planet is bloody huge. I mean, yeah, you stand it up next to Jupiter or, you know, the sun, and it may look like a little pale blue dot indeed, but as far as habitable, non-cataclysmic celestial bodies go, our Earth is pretty damn spacious. But it's an interesting notion, isn't it? How big could it get? Obviously within the parameters of hypothetical geology, and more importantly, is there anything out there that's making us bigger? Well, let's take a look. Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your dismodified floating voice Jack Finch. As today, we curiously ask the question, how big can the Earth get? How big your planet could and would get is merely a matter of how big your ego is. Hey, I'm not saying there's any kind of clear correlation, but who knows, it might put things into perspective a little bit. You see, although it may sound a little bizarre, the thought of the Earth growing in size hasn't always seemed as outlandish as it now seems, given the fact that we've figured out the whole plate tectonics thing, and yeah, we're all pretty much decided that the Earth isn't going to head into any kind of unexpected growth spurt. But let's not solely focus on that for the moment, and instead cast our gaze back quite a little bit, well, quite a lot, all the way back to 1834, to a time where the legendary naturalist, geologist and biologist, the father of evolution himself, Charles Darwin, was careering his way across the 7 seas in pursuit of more unrequited knowledge. During the second voyage of his famous HMS Beagle journey, whilst in Patagonia, Darwin investigated a series of stepped plains that featured a set of raised beaches, which indicated to him that a huge area of South America at some point in time had been uplifted to its present height by a succession of elevations. Essentially, what he saw was that the Earth indicated that somewhere beneath the outer crust, a shifting in the visible landscape required the gradual expansion of some sort of central mass. It got him thinking, and later in 1835 he extended the same concept to the Andes mountain range, indicating that its existence was evidence of a curled enlargement of the Earth's crust due to the action, again, of one connected force. Although only a brief moment in Darwin's geological endeavour, he later moved on from this idea and instead proposed that as mountains rose up from the Earth over the ages, in turn the ocean floor subsided, explaining the formation of coral reefs and ocean atolls. Obviously, Darwin was a genius, and he was certainly onto something, if only if it wasn't for those pesky plate tectonics, but it gave rise to a brief school of thought encapsulated in a theory known as the expanding Earth hypothesis. In it, this theory stated that the position and relative movement of the continents of our planet is at least partially down to the volume of Earth increasing. They literally thought the Earth was getting bigger. What this theory mainly focused on, though, was the notion of mass addition. To cut a long story short, although Darwin's findings were purely observational and he never stated a clearly definitive stance on the matter, it gave light to many other geological minds of the time. One of them was Ivan Yarkovsky, who in 1888 thought that he'd cracked the mechanical explanation of gravitation and suggested that our Earth was constantly absorbing some kind of strange strange material, some sort of ether, which was then transformed into a new chemical element, forcing our planet and thus every other celestial body in the universe to expand. In other words, the addition of mass. Essentially, what this theory of mass addition proposed was that our planet, as well as every other celestial body in the universe, through gravity was like some sort of giant spherical magnet, picking up billions of metaphorical iron filings that existed somewhere in the cosmos as an unknown chemical element, and through an unknown process converted that into regular matter, which somewhere down the line caused mountain ranges to form over millions and millions of years. And yeah, obviously that indeed sounds incredibly outlandish and pretty darn impossible given our current understanding of geology, but back then it was pretty revolutionary thinking. You see, the thing is, in some ways that is exactly what happens. I mean, think of it this way. It is a well-known fact that our Earth is constantly acquiring mass. Don't believe me? Just ask NASA. As the most recent readings indicate, every day around 100 tons of meteoroids, fragments of dust and gravel, sometimes even large rocks, enter the Earth's atmosphere. Now, of course, the majority of this cosmic debris burns up in the atmosphere and then lands back down as dust, but technically speaking, this process is indeed evidence of mass addition, albeit incredibly tiny. And obviously, perhaps also not the straw that we need to break this particular camel's back. You see, however small, this accretion is only a minuscule fraction of the actual mass increase needed to support the expanding Earth hypothesis. After all, if you want to move mountains, it's going to take a little more than a few specks of space dust. However, there is another incredibly damning caveat to add to this pile of expanding Earth. If this addition of new mass would indeed over billions of years increase the size of our Earth, surely that increased gravity would have altered the orbits of not only our planet, but every other planet in the solar system. That includes the moon's orbit, which of course would seemingly be under the same effects of Earth, and then in turn affect both of their orbits. Yeah. Now we have the leading theory of plate tectonics to explain the very clear movement of our planet's continents, but still, it's an interesting thought, right? Although clearly contradicted by the scientific community, the expanding Earth hypothesis was onto something in some respects. Technically speaking, our planet is gaining mass every single day. And how big can it get? Well, maybe we should ask this question in like a few trillion years.
Sun. Fun. Right now, the Earth is at the perfect distance to enjoy the life-giving benefits of our sun. Things aren't too hot, things aren't too cold. They're just right. But what if the sun lurched forward a bit and got closer to planet Earth? What would happen then? Hello and welcome back to Life's Biggest Questions. I'm your host, Rebecca Felgate, and today I'm asking, what if the sun moved closer to Earth? Sizzle, sizzle, fry, everybody dies. Before we get into this video, I want to ask you guys why you think we have never given the sun a name. I guess we did name it Sun until we started calling other stars suns, and then it seemed kind of insignificant. All of the other planets in our solar system have a name, and I think our sun should have one too. I'd call it Shale. I don't know why, it just came to me. Also, while you're down there naming the sun, why don't you leave this video a thumbs up and share it with a space-loving buddy. I also learned something pretty interesting just now, and I wanted to share it with you. This is the universal symbol that scientists have come up with to denote the sun. A circle with a dot in it. So while the sun doesn't have a name, it does have a symbol. Pretty cool, right? So, the sun. Right now we are living in a astrobiological habitable zone, the circumstellar habitable zone. We sometimes just call it the Goldilocks zone, as it is just right for housing life as we know it. Anyway, the conservative habitable zone falls within the optimistic habitable zone. Planet Earth almost is perfectly in the middle, but there is one planet that is the most habitable, seemingly. Gliese 667cc falls right bang in the middle. The exoplanet is 23 light years away from us in the constellation of Scorpius and could be a good option for future colonization. Habitable zones are places where surface liquid water is likely to be discovered, which is a key element in life, again, as we know it. The thing is about the habitable zone is a concept which has very much been created with our needs in mind. It's habitable for us. Humans need water, light, oxygen, but we have evolved in response to the conditions of our planet. Because of the way Earth orbits the sun, it's never the same distance away day to day. At its farthest, the sun is 152,095,701 kilometers away for us. At its closest, the sun is just 147,098,074 kilometers away, a small difference difference in the sun's distance, and when I say small, I just mean a few million kilometers. It's all good. But if the sun was significantly closer, well, that would be a problem. Our neighboring planet Venus, the second rock from the sun, is just 108 million kilometers away from the sun, and it's El Scorchio there. The mean surface temperatures are around 462 degrees Celsius or 863 degrees Fahrenheit. The factors aren't the same as Earth, but nonetheless, Nout can survive upon Venus's blistering surfaces, including water. If there was any anyway, it would have evaporated long ago. The thing is, while the sun does move, it orbits the center of the Milky Way, taking us with it as it goes. It isn't in the business for lurching forward closer to us. That just isn't how it works. We are locked into a gravitational orbit with the sun, and now unless there was something supermassive that came along and gave us or the sun a good shove, that orbit will remain steady. If the sun gained mass, then Earth would be drawn closer to it. But being a burning hot ball, the sun is constantly shifting mass to energy. It can't gain more. Although, just to make things a little bit more complex, it seems that the more the sun converts its mass into energy, the bigger it gets. Let me explain. The sun fuses hydrogen into helium, making it burn baby burn. It seems that the sun loses mass at the rate of 4 million tons a second, which sounds like a lot, but comparatively to the size of the sun, this is pretty negligible. So while this doesn't affect our orbit, this does mean the sun is getting hotter, and as it gets older and bigger in terms of flame size, things could be a bit of a problem. In that respect, the sun will move closer to us. The sun is currently around 4.5 billion years old, and in around 5 billion years, it's going to reach its end of life phase. Before that, in 1.1 billion years, the sun will have expanded by 10%, making its rays hotter and brighter to Earth. In 3.5 billion years, the sun will be 40% brighter than it is now. This is danger time for the planet. 10%? We might be able to deal with. Perhaps by that point, human development could create giant reflectors to send some light back into space to stop the sun heating up our surface temperatures. Even then, this will likely be enough to melt what may be left of our polar ice caps, which would mean huge floods to coastal areas, whereas hotter temperatures across the globe will increase droughts in landlocked areas. If the sun got much brighter than that, and the flames got closer, well, our Earth would be irreparably scorched. First, the lakes will boil and evaporate, and then the ocean. We would likely be long dead by then, but if we weren't, kissing goodbye to our water would be a final nail in the coffin. When the sun reaches the later part of its life, the red giant phase, it will expand very close to Earth indeed. It is calculated that the sun will swell so large that it will consume Mercury and Venus, and it is quite likely that Earth will be sucked in too. Goodbye Piccadilly. Farewell Leicester Square. Our distance to the sun determines our seasons, ocean currents, climates, and radiation on Earth. If we were to shake up that key factor, well, it would very much upset the force. A closer sun, in simple terms, means that we would be knocked out of the habitable zone, which again, in simple terms, means death for all. Maybe by the time the sun does expand and its flames get closer to Earth, humans will likely have moved to a new habitable zone. Maybe. Maybe by this time Mars will be looking pretty cushy, or if we found a way to travel the speed of light or faster, well, maybe we could haul ass to another star. Sorry, sun. Thanks for all the memories. Good job we never gave you a name so we couldn't get too attached, right?
Hello and welcome back to Life's Biggest Questions. I'm Rob Mackenzie Lafergie. We humans love to think about the future. Whether we're daydreaming about potential technologies or worrying about potential disasters, we love to think about what might happen days, weeks, and even years from now. So today, let's explore what the world might be like a century from now. So get ready, it's time to ask the question, what will the Earth look like in 100 years? Well, as I'm sure you can guess, the Earth could look any number of ways in 100 years, depending on the trajectory we follow. And one factor in particular will make a huge difference. You guessed it, climate change. Sure, we'll see technological innovation over the next century, but most of that is damn near impossible to predict. However, if we can't stop or even slow climate change, there are a number of effects that are pretty darn certain. So, today we'll look at 3 different Earths. One where climate change was allowed to continue at the current rate, one where we kept warming down to 2 degrees, and one where we have defeated it. Let's dive in. Before I begin, I'll just pause so that all the climate change deniers can go down into the comments and yell about how I'm a shill for big wind or whatever. You done? You sure? Okay, now let's dive in. I'd like to end this video on a high note, so let's start with a world where we did nothing to stop climate change. First, and most obviously, the world would be warmer. That's one thing that Al Gore got right in his documentary. It's projected that, should we continue our current course, the world will be 4.5 degrees Celsius warmer in the year 2100. That's about 8 degrees Fahrenheit for the Americans out there. So by 2120, it would be even warmer than that. Now, I'm currently entering a Canadian winter. I actually have to go shovel the driveway once I finish this video, so I wouldn't mind an extra 5 degrees right about now. But for those in warmer climates, the heat will not be so welcome. For example, summer in the tropics will be several degrees warmer all summer long, leading to mass extinction of certain species who can't take the heat, and even making some areas unlivable for humans. And while humans can generally move to another place, this would throw off animal ecosystems a huge amount, causing many to die off without being able to adapt. This melting ice would contribute to higher sea levels, causing incredible amounts of flooding on the coast. Some coastal cities would be made unlivable. But this wouldn't only affect the coast. Other areas could see more extreme precipitation and storms, especially areas in the northern hemisphere like Canada, Greenland, Northern Europe, and Northern Asia. While some places would see way too much water, others would be wishing for more of the stuff. There would be a great many droughts worldwide, with some predictions stating that we could see severe drought across 40% of all land, compared to the 20% we have today. This would be seen the most in the Mediterranean, Southern Africa, South America, and Australia. If you think Australia has it rough now with the wildfires going on, that's nothing compared to what we'd see in 100 years. This would cause humans to migrate to other areas where water was more abundant, or else live under strict water consumption guidelines. This congregation of humans as they flee drought or flooding would lead to even more overpopulation than we have today, with more and more people trying to fit into less and less space. We would see a great amount of development in less at-risk areas, but even those areas would still be subject to intense storms. It would be hard for anyone to avoid the effects of climate change, and for many, especially those in poorer areas, this would likely be a death sentence. Next, let's talk about what would happen if climate change was slowed. Based on what world governments are claiming they plan to do, it seems that a middle ground where climate change was slowed but not stopped will be the most likely scenario. But unfortunately, even if we reach our ideal goal of only 2 degrees above pre-industrial levels, we'll still see serious effects. The ice in Greenland would melt every summer. Ice will continue to melt on the poles, disrupting wildlife like polar bears. Oceans would continue to acidify, leading to the death of coral reefs. Nature would be greatly harmed. Plus, many of the things mentioned in the worst-case scenario would also be happening, albeit on a smaller scale. We'd still see droughts, still see wildfires, still see natural disasters like hurricanes. All of this would be worse than it is today. This would cause massive displacement of humans whenever a tragedy like this occurred, making certain areas much less ideal to live in. However, that isn't to say we shouldn't be making an attempt. Every degree of warming we prevent saves millions of human lives, so it really is our duty to do what we can. Okay, I'll hop off the soapbox now and finish up with a fun option. What if we managed to defeat climate change? Well, this would require a few things. For one, it would require efficient carbon capture technology. This is still in its early stages right now, and it's unclear whether we will ever find a way to capture enough carbon to turn back the clock on climate change. But in an ideal future, we will have found a way to do so. We would also likely have transitioned to renewable and cleaner resources. This would, of course, involve solar and wind power, but would depend heavily on nuclear technology. Despite the dangers nuclear poses, it is believed by many to be our best chance of providing great amounts of power while posing minimal danger, so long as safety procedures are followed. We would have transitioned to electric or even nuclear-powered transportation, be it planes, trains, or automobiles. I mean, probably not trains so much, they're so 20th century, but you know what I mean. It's even possible, some might say likely, that the Hyperloop put forth by Elon Musk, aka Tony Stark, would become commonplace. This would see underground pressurized tubes built under cities, allowing fast, safe, clean transportation throughout the world. Speaking of Musk, with all this clean energy around and increases in technology, there's a good chance we'd start exploring and even colonizing other planets. While most of the effects of climate change will have been avoided, we'll still have a population problem on our hands. But hey, if we found a way to ship people off to other planets, we'd be able to not only fix our population issues, but also avoid the extinction of our species, should something unexpected happen to Earth. One other possibility, which might seem good or bad depending on your disposition, is that we would find a way to create incredibly lifelike virtual reality, almost like San Junipero from Black Mirror, or The Matrix minus the robot things. This could see humans exploring not space, but a virtual world, where you could adventure through Middle-earth, soar high in the sky like Superman. Or, surf Reddit, I guess. This would allow more space and resources to be available for those who chose to live in the real world, which would be increasingly important as medical technology allowed us to live longer and longer. And life would be pretty dandy in the real world, since most of our work will be done by our robot servants. And now we return to our question, what will the Earth look like in 100 years? Well, if we don't do anything about climate change, we'll be in rough shape. Mass animal extinction, great human suffering and death, and unpredictable and dangerous weather would abound. If we manage to slow it, we'll still see all that stuff, but on a smaller scale. But if we find a way to stop it in its tracks, and even reverse some of the effects of climate change, we could see an incredible world full of amazing technology. Robots would do most of our jobs for us, so we could spend our time relaxing, or having adventures in incredible virtual worlds.
We've covered a lot of the weird and wonderful cosmic mechanics of the universe over here at Life's Biggest Questions, from black holes to white holes to dark energy and neutron stars, and seemingly it's relatively entertaining to fit them into differing hypothetical models to ponder on what impacts these cosmic wonders would have for life down here on Earth. Perhaps one of the most perplexing of these then are the notoriously rare pulsars, the product of a cosmic event that occurs under extraordinarily rare circumstances in the life cycle of a neutron star. But what would happen if our planet had hit the intergalactic jackpot? What would happen if Earth found its home amongst these weird enigmas of physics? Well, let's find out. Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice, Jack Finch, as today we curiously ask the question, what if Earth orbited a pulsar? Anyway, it leads us to an important opening notion. Are there in fact any known planets that have ever orbited or are already in orbit of a pulsar? Well, yes, in fact, perhaps only one that's ever been discovered by science. But before we blast off over to that insanely awesome cosmic phenomenon, let's first take a look at exactly what these things are. In our last video, we spoke about what would happen if our sun ever turned into a neutron star, the life cycle of a particularly large solar body that after going supernova turns into one of the strangest entities in the known universe. If you'd like to find out more about that particular neutron star in question, then make sure to head over to our playlist to find out more. But for those of you that aren't so inclined, we'll rush through the basic mechanics. Every star in the universe has a life cycle, and under certain circumstances, particularly large stars have a habit of getting so big that they explode in a supernova of celestial destruction, leaving behind a neutron star that's incredibly small but also incredibly dense and has one of the strongest gravitational forces in the known universe. There are thought to be about 1 million neutron stars in the known universe, but an even rarer version of a neutron star is known as a pulsar. And if you thought neutron stars were weird, then these guys are much more bizarre. In exactly the same manner that neutron stars spin rapidly and produce incredibly strong electromagnetic radiation, a pulsar releases that radiation along a narrow beam, almost like a lighthouse. And because a pulsar spins at such a consistent speed, they produce a very precise interval between pulses, hence the name, and function like some weird cosmic lighthouse out there in the void of space. Now obviously we're teetering on the edge of theoretical physics here, but there's actually quite a lot of evidence to support the mechanical workings of a pulsar. In fact, the first ever pulsar was discovered way back in 1967 by Jocelyn Bell Burnell and Anthony Hewish at the University of Cambridge, who noticed that a solar entity under their observation flickered with precise pulses and deduced that it must have something to do with the rotational spin of the star under some kind of emission of wavelength energy. Obviously, there was much more to their work, and their efforts even earned them a Nobel Prize in Physics. Good job, guys. It leads us to an interesting interesting point for our theoretical planetary orbit though, because the pulsar that Bell and Hewish first discovered, which is now named CP1919, produces radio wavelengths as its bright burst of magnetic radiation, but in fact, pulsars have also later been found to produce radiation in the form of both X-ray and gamma ray wavelengths. Well, you may think that's a bad thing, and well, it is, because any solar body that produces narrow beams of deadly radiation spells bad news for any exoplanet caught in the pulsar's orbit, and it quickly makes things incredibly difficult for us as a hypothetical species to survive. In fact, it's incredibly rare for any kind of planet to orbit a pulsar, but they do in fact exist. Hold on to your hats, but PSR B1257+12 is a pulsar star located around 2,300 light years away from our sun in the constellation of Virgo. Thankfully for us though, it's also referred to as Lich, as in yes, the undead necromancer of myth and legend. What makes Lich so damn interesting though is that it's a pulsar star that has 3 different planets in its orbit, an incredibly rare celestial phenomenon. Those planets are known as Draugr, Poltergeist and Phobetor. Pretty damn heavy metal, right? Well, actually, it's funny we should say that, because life on any one of these planets would be damn scarier than any Lamb of God and Cradle of Filth album combined, and we can only imagine the terrifying events that would occur if Earth was one of those unlucky planets in orbit. Because of the mechanics of a pulsar star's orbit, having a pulsar as a solar entity would be like a giant strobe light flashing on and off for eternity. Every day would be day, night, day, night, day, night, every second passing by as light and dark in an instant. That would only be during the actual day though, and if we accept that our Earth would have a similar orbit that it does now, night would be pretty much the same, giving everyone on Earth 12 precious hours to rest their eyes from the constant strobing chaos and chance to figure out how on Earth we get back to our warm, loving, life-giving sun. It would be like being imprisoned in a really crap disco that you didn't ever want to go to, with a terrible DJ and no friends, only forever, endlessly, and you can't escape. Also, it's pretty important that we mention the light that hits you during the day is perhaps some of the most deadly radiated energy forces in the universe. Supercharged X-ray and or gamma radiation that would certainly strip the very iron from your blood, turn your eyeballs to jelly, vaporize you at the molecular level, and also all of the above. Yeah. And I know we've been trying our hardest to steer away from this particular hypothetical conclusion, but if Earth orbited a pulsar, it's very likely that everyone would die and our civilization would be over in a matter of seconds, vaporized by a literal cosmic tornado. Not only that though, but once we're all fried to oblivion, it would happen over and over again, frying us with super intense electromagnetic radiation at regular, precise intervals. So precise, in fact, that our molecularly charged civilization would be potentially more accurate than an atomic clock, and hey, perhaps we could even serve as some form of time-telling device for a far advanced alien civilization that were wise enough to know that orbiting a pulsar would be a really, really, really bad thing to do.